Okay, so it's 9:05. I'm gonna start. Yeah, I wish there was a way to blow it to full screen too. So, I'll be doing the JavaScript workshop. My name is Zachary Santana. So the first thing is I wanted to go over what is JavaScript. I displayed a little bit of history here, but JavaScript is basically the dynamically typed the language that lets you do stuff for websites. So that's why people use it. So if you wanted something like someone clicks something and it does something special, you'd be using JavaScript. HTML would be the body and CSS would be the styling. So Java has 7 primitive types. We have a number. This kind of goes over like the traditional real number set, or like 1, 2, 3, 3.14. Usually languages split this up, but for JavaScript we'll just define it as a number. A string, we can use double quotes or single quotes. If we use backticks, we can actually access the variable in our code. Other languages use a format method to do this, and they would put it as an extra argument. But in JavaScript, we can just use backticks instead, and we can actually access the variable using this notation. It also has booleans with true or false values, nulls, undefined, symbols, and big ints. So with these primitive values, we can do operations to actually perform some type of thing on it. The logging method in JavaScript is console.log. So if I go into my Visual Studio and I make a new file by right-clicking over here on the File Explorer, and make a new file, and I'll call it script.js. JS being the default JavaScript file extension. I log hello. This would just print hello anywhere that this is running, but we're not actually running it anywhere. So just to begin, I'm going to make a HTML file, and I'm going to open that in Chrome. That way we can see the output in Chrome's console. I'm just going to make a very basic HTML. We had a HTML and CSS workshop yesterday or earlier today, but I'm just going to wrap HTML, and I'm going to put in the footer the script tag to be able to autocomplete it for me. Really. So I want to point the source to the file. So the file that I made personally was script.js. So I'm going to put in here script.js. And I'm just going to open this file in a web browser, like so. I'm just going to zoom in real quick. And that's good. If anybody has if they want me to zoom in more, or if that's good enough. I'm just going to put this to the side and put this one. And since I'm not really going to be editing the files anymore, I just have the index.html, which points to the script, and I have the script. I'm going to kind of close the File Explorer so we can see more of the code. So if I right click in my browser and I click, not inspect, and I look at the console, I'll see hello in my script.js that I printed hello. So that's how I'll be looking at the JavaScript outputs. So first thing I want to go over, did I miss much? No, I just opened Visual Studio Code. I made 2 files. I made a script.js, and in the same folder I made an index.html. It doesn't matter what you name them. You just want to open the index.html in your browser, like so. And in the footer or head, you want to put the script tag. And the source points to whatever file name that you named your script.js. So if it was like mycode.js, you put mycode.js here. Then in your Chrome browser, after you open it, you're going to right-click Inspect and go to Console. So I manually typed it in here. So it has my, like it's located on my C drive, users, my username, my desktop, workshops, JavaScript, and then I put the file name. Sometimes some computers already have it. You can right click a index.html and there's an open with in like File Explorer, and you could open with Google Chrome. If you don't see that option, then just copy the path of the file to Google Chrome. That way it runs the file in Google Chrome, and then you just open the console to see the output. I don't think I can zoom in on the output, sadly. No problem. Okay, so I'm going to close this back up so we can see more. I'm going to continue. So as I was saying, the operators in Java, you have the greater than sign, less than sign, you have the typical, you have equal equals and equals equals equals. So the two equals just compares like kind of loosely. This 2 is a 2, but the 3 equal signs compare type 2. This is a string, and this is a number, so they're not equal in that regard, so it'll return false. I can show you that here. If I had like 2, and I do 2, I also log 2, 2. I refresh it. The first one's false and the second one's true. So each type has their own set of operations that you can use on them. So other than those basic greater than and less than signs, for numbers, you could also, let's say we wanted to add them, or we wanted to this line. We wanted to multiply them, we would use an asterisk. If we wanted to subtract, we would use a minus sign. If we wanted to divide, we could use this. If we wanted to do a module or modulus, we would do this. So some people might not know what this one does. This one just gets the remainder, so if we had a 5 here, it would return a 2. But if it was a 6, there's no remainder, because 6 divides nicely into 3. So we would get a 0. And then the final one is exponential, which is 2 asterisks. This means 5 raised to the power of 3, which is 125. So when we run this code, it'll give, I'll just delete the basic ones like these 3. We can see the output of these 3. So the first one's 2, is the remainder is 2. The modulus is 0, and exponential is 125. I just want to go over some of the important ones. Like for string, we could access a index like that. So if we access the, I spelled hello wrong. Access the third. This is a 0, 1, 2, 3. So it's going to print out an L. We access the fourth. It's going to print out O. So you can also do concatenation in JavaScript with like this. This one concatenates 2 strings. It'll print exactly the same as if we did it 1 string. And if we wanted to embed some type of quick calculation or something, we could do the same thing with the backticks. Let me change my double quotes to backticks. Let's say I put 100 divided by 2, 3. It'll do the calculation for me right there. Yeah. So my index.html is really simple. I didn't really do anything declarative or semantic. I just wanted to get some environment running for my JavaScript. So I put HTML and I wrapped a footer, and then I put a script tag, and I put the source pointing to whatever file. Does that help you? Do you have any questions? No problem. So for booleans, we have the stereotypical the comparison operators that before they would return a boolean, like the greater than 5. To return a boolean, this one would return false, for example, and let's say we had like less than or equal to 8 or 7. This one will return false as well. The equivalence operators or equality operators, like the one that loosely compares them and the one that strongly compares them. And then it has a stereotypical, what most languages have, which is the not and then some value. So not greater than 50 is greater than 10. 50 is greater than 10, but it's not. So it's going to return false. And to do console.log is our method for logging. Other languages, JavaScript uses system.out.println. Python uses print. This is just this method's, this is the way we log into the console or whatever we're running it on in JavaScript. So whatever I put in here, it's going to log. That's how we're seeing the output in Google Chrome. Yeah. So the equality operators is, this one would be loosely typed, and this one would be strongly typed. Like checking the types. So this one doesn't check the type of the two variables, it just kind of compares them, and 2 is equal to 2. But this one checks the type. This is a string, and this is a number. So the first one's true, because it just checks, is it 2? But the second one checks, is it a string in 2? And this is a number in 2. So that's the difference between the two. No problem. And if we wanted to do the final set of Boolean operators, we could have some value, or I'll make it less complicated. We'll have some value, and we can say and some value. We could say or some value. A lot of languages use this exact syntax for that. Other than that, we had like type null. But we can also see that null, we get the type of null, that it'll say it's an object. So that's pretty interesting, but like it's just something that like it's a actual data type, it's more connected to all the others. If we just define a variable, then we printed it, it's going to start as undefined. And if we tried the type of, it's going to be undefined. So JavaScript is pretty loose in that regard. JavaScript isn't necessarily object-oriented, but everything can be an object. Like you can define objects, and you can use object-oriented code with JavaScript. But it's not as object-oriented as Java. It's more, a lot of the structures are loosely and typed, so it's not as abstract and integral like that. It's not as integrated as Java is. It's mostly just used for browsers because it's really simplistic to run. So most browsers can just add it to their environment, and it doesn't harm the runtime as much as other languages. So I'll move on from types and operators. So program structures like let, while, if, switch. So I'll go over the slide a little more. So for those of you that are kind of new to coding, I'll explain some of them. While and for means a loop. It does the condition while it does it, like while it's true. If does one run, and then else does if not that if. Like if the run did not run, run this one. And I'll explain the differences between var, let, and constant. Which first I will do. So if we have a var, it's global scope. So this means that if I define it here, I can access it globally. Now this won't be too important for this workshop, and I really won't be able to show how we can access it globally, but that's the difference between var and let. Let does it within its block. So usually we'll have a block of code signified by the curly brackets in some way, whether that be like a function or an if statement or for loop. But this block of code, if we define the let in here, it's isolated to this block of code. But if we define the var in here, you can actually use name1 here. So if you wanted to see like a quick example of this, I could just print name1 and it'll print Tony. But if I try to print name2, which is the let, which is combined, which is like squeezed into this curly bracket, its block, is going to say it's not defined. So that's the difference between global and just like block scope. That's really the only two differences. A lot of people are going to let from var. Var is the older one, because var, if I tried to name a name1 here, it would redo it. If let is outside the block of code, is explosive of everything outside of small blocks of code. I'm not sure what you're trying to ask. Let is contained within its brackets. Var is global scope to the environment, if that makes sense. So var will define it for all of them. Yeah, it's like if I moved let out here, if that's what you're trying to say. Yeah. If I moved a let out here, then it would be contained within this scope of this file. So yes, if that's what you're trying to say. It's like kind of like the same. Although I could define var out here as well. Var is just globally scoped. Anywhere I define it, it'll get redefined or defined. Let's block scoped. So I'll move on. So let's say we wanted to look at the difference between those and constants. So if we define pi like this, and we define a constant as the same value, and we printed both of them, they'll be exactly the same. I'll separate a colon between them. Should have called this constant this pi2. Bad. Did I put constant wrong? Oh no. Unexpected token constant. Oh, I referenced constant instead of pi2 there too. That was a slip of mind. Oh no. Anyways, we'll have them print both of the same things. But the importance of constant is that, like other languages, you can't mutate it, you can't reassign it. So if I reassign pi to 5, or like 3, I'm an engineer, and then pi2, I tried to reassign it to 3 as well. I run it, it'll say assignment to constant variable, so we can't reassign it. JavaScript is mainly used for some interactivity. Let's say I wanted to click something on a HTML page, then that would be using JavaScript. Unless it's a button, which if you wanted to do anything other than go to a link, it's most likely JavaScript. If you wanted any animations, it's either you use JavaScript or you use something that does use JavaScript. So it's basically the movement of the page and like stuff that'll happen on the page when the user interacts with it. That's mostly what JavaScript's used for. Almost completely web development. It's the action to HTML and CSS. So I'll move on to loops. So if we have a while loop and we say, I don't know, counter is less than 0, and our counter is -5 to begin with, and we add counter each time, and we log it in the console. So run, let's say we'll just log count. Run like expected, -5 through -1, because once it reaches -1, it's no longer true, and it'll stop the loop. So if I printed something out here, it'll run after all that. If we wanted if, it's really similar to other languages in that we can just do if, and then we could say 10 is greater than 0. We have some Boolean value or something that evaluates to a Boolean value. Then it'll be true or false, and it'll run the if. And we could also have else, and since this is true, the else will never run. But let's say it was like 10 less than 0, then this is false, and the else would run. So I'll just print that real quick. Greater than 0. So if I run it currently, it'll run the second one, 10 is less than 0. If I run the greater than 0, then it'll run my first one because it's true. Besides if, we also have a switch statement. So if we had a weather, said it was rainy, we tried to define a switch statement for it, we would put the variable that we want to compare to other variables inside of the condition for switch, and we would put the comparisons, or what we might want the cases to be, as cases like this. So if it's rainy, we'll log that it's rainy, and I'll do 2 others cases. Oops. I mean to put the case breakdown there, but it doesn't really matter. Just gonna move it back up. So let's say it's sunny. It's sunny. And let's say I had a default case. Said, we don't know. So these break statements are a lot like the endings of an if statement, except for JavaScript you don't need to put correct. Yeah, these I did it by instinct. Traditionally I do semicolons. I'm just a semicolon person. You guys don't have to be semicolon persons. You guys could do it just like this, and it'll work fine. So if I run it, the weather's rainy, it tests this with this one, and it says it's rainy. But let's say we had like something like we added another case that incorporates one other case. Explain these to double quotes versus single quotes. Double quotes and single quotes are about the same. Let's say I wanted to use single quotes in my string, I would use double quotes over here. That's the only difference. There is backticks, and backticks, I'll show you what they do with this example actually. Incorporate into it. Let's say we wanted a cloudy one that says rainy and cloudy, but we wanted to do the rainy condition as well. But we would not incorporate the break tag. For rainy, it would still say it's rainy, but if we change the weather to cloudy, say it's cloudy and it's rainy. Now, maybe you not want to look like this, so you would implement your code differently, but the important part is the break statement ends the code for that case. String versus char, there's only the string variable. In other languages, it is string versus char, but in JavaScript, it's just the string variable, string data type, and it doesn't matter if you use that or that. I told you I would use backticks as the alternative. So if I use backticks, which you can find next to your 1, they look like that. They look a lot like single quotes, so just don't get confused. And I wanted to incorporate a variable, which is what backticks are for. I want to say weather. I said it's kind of renders all this useless, but I'm just showing the use case for it. And I said it's the weather variable, and I ran it. It says it's cloudy, it's rainy. So I could incorporate this up here, and I could put like gibberish. It will run the default case. We don't know, and it says it's food to buy, since it's the default case, since I put gibberish. But the important thing is that this accesses a variable. Is anybody confused? Can I move on? All right, if you guys have any questions, just hop in. So I went over while earlier, but now I'll go over for loops. We kind of implemented what a for loop does in our while. So say let I equals 0, and we'll just do a traditional one. I is less than 10, and we'll add I. So this part is an assignment. So you assign a variable some value. This part is a Boolean expression, something that evaluates to a true or false value every time it's ran. So I less than 10 is a Boolean value. Other Boolean values you could put like not count or something. and you could be really inventive with it, but most traditional uses of for loops we do I less than 10. This is kind of like a little statement that will be ran after each code. It edits some variable in some way usually. Can we use I++? We can totally use I++. They have small differences. I could explain them right after I explain for loops. If I forget, just remind me. Sorry about that. So if we had a for loop and we printed the I, it would just go from 0 to 10. It's really simple. Or 0 to 9. 10 elements, 0 to 9. Because once it reaches 10, 10 is no longer less than 10, and this will be false, so it will not run the for loop, and it'll break out and go to line 4, 5, etc. So that's most of the conditions. I++ and ++I. Let me do an example. We had I equals 0, and we had j equals 0, and I wanted to show the outputs of what they returned, because they accomplished the same thing, but what they returned. The first one, you see 0. This says return I, like put I in console.log, and then add 1. So if we were to log I afterwards, and I'll remove the j just for now, see 0 then 1. It says return I and then add 1. So now afterwards, every time we use I, it'll be added with 1. For the other one, I can eliminate j and I can just edit this code. We do ++I. It'll add 1 to I and then return it. So now we'll have 2 1s. So it matters if we want the return type. For a for loop, we don't actually want the return. We don't care what we use it as. We don't have to get clever with it or anything. We can use either one. Some languages use ++I as I don't know, just like pre. Like most people are inclined to ++I. Some languages use I++, like Java. So now that we've done conditions and stuff, let me go back to the workshop. So there's 3 object types: functions, arrays, and objects. We say object types for each one because we can treat each one as an object. Objects are just a collection of like properties that you can use and define. It's like our traditional objects in other languages like Java and stuff. Arrays are just like the arrays in Java or any type of set, really, except in JavaScript, they're really cool. I'll show you some functionalities really quick. And functions are like, in Java, if you're familiar with it, it's like a runnable, but that's how we'll treat them. But they're also just objects that you can just move around, and it's kind of like a new feature that was in Java 8. Or if I compare to Java a lot, I'm trying to relate to people watching the workshop. If you guys don't get anything, just ask me a question. I can explain it in different words. So let's go into the objects version of objects, like the how to do objects with properties. So if we wanted to define a car that was a Tesla, and the model is a Roadster, and the year was a 2024, you can define any type of data type inside these properties. And now outside of the little curly brackets, which define as properties, we could log my car, and we could access any of them. You see my text editor, Visual Studio Code, already puts them right here. Puts my car, puts year, puts model, and it puts make. The others are kind of defaults that it tries to suggest you, just in case you might need them, but you don't really need them. So if we did .make, and I capitalize C, it'll say Tesla. I have to say the data type, or they just constitute. So they're scoped not within anything, kind of. They're scoped within the class, within the object. So my car owns them. Nothing else. If I try to do make here, it's kind of like I'll move the mic a little closer if that helps. It's kind of like if I try to do make here, it won't actually print anything because it's scoped within car. It's owned by car. I think that's the best. Explanation. It's owned by car, so nothing else can touch it. So it's not like it's not like scoped anywhere. It doesn't have let const or anything, and we can redefine it actually. So if we did my car make equals I don't know, we switched to BMW, refreshed it. Now it's BMW when we access it here. So we've changed it permanently. Well, not permanently, we could rechange it again. So aside from this declaration of an object, so they're not constant, but my car is, yes, that might have been confusing. Thank you. That's a good point. I put constant just so I could vary it up a little bit. We could do let, and now we could change my car completely. Now we could change it to like 5. Now instead of accessing make, and we just printed my car, now we just get 5. We've made this whole object into just 5. When I said const, that's so this cannot happen. This will be an assignment error. So we use const if we just don't want the person to change the code. If we personally don't want to change the code. So if I never want to reassign my car, I'll do const maybe as a reminder to myself. Const is just like what type, like what data assignment do we want? Do we want let, which will be in the scope? Do we want var that'll be in the global scope, or do we want const that it's like let and we can't redefine it? So I didn't use it in this case for any particular reason. We could use let or var. There's nothing special going on with that. I'm sorry about that. But other than this direct declaration of an object, we can also define a function that'll make us objects. So let's say we wanted to define kind of like the equivalence of my car as a function. We could say this. We could say this.make equals make. I will exempt the semicolons, but I forgot these curly bracket right there. This.model equals model, and this.year equals year. So what I'm doing here is I'm accessing the this, which is the whatever returns from this function, and I'm setting it like its property to the parameter that we pass inside the function. So this car will return itself, which has these 3 properties. This keyword represents the like I guess the parent scope usually, if it's something that can have at this keyword. Like if I just had curly brackets, usually can't have at this keyword itself. So if I were to call this, and I made a new car, I'll set it in a variable. Made a new car, and I wanted the make and model to be BMW. It's an i3, and it's a 2021. Notice how I don't really define. Did I spell new car 2 wrong or something? That's weird. Possible. Is my Java showing? Did I do something wrong? Oh yes, my Java is showing. I typed the data type there. That's a big boo-boo. Supposed to type let, var, and const. We were just talking about it too. Probably why I got confused. But if I printed just the my car, it'll print the object like this. But that's not what I wanted to do. I wanted to print car2 that we made with the function. So if I wanted to access make, model, or year, and I wanted to access its year, which is 2021, it'll say 2021. So now we've defined a function that will make us objects like this. And then that's like the 2 ways that we kind of use objects like this. We could also define a class, which I'll go over in a little while. So let's say we had like some type of string, just my name. There's just some like manipulations that we can do and we can show. Just wanted to go over them quickly because pretty important, but they're pretty similar to other languages. We wanted to print the length, which my name is 7 characters last time I checked. And we wanted to change the name to uppercase. We could run that function on it. If we want to change it to lowercase, we could run this function on it. And we just refresh to see the output. We can see 7 characters. It changed all the characters to uppercase and changed all the characters to lowercase. if we wanted to test if my name includes something, we could do ACK. My name does include ACK. When we ran it, it'll say true. But if we said ACKS, some variation that's not in my name, it'll say false. So these are just some basic string methods that are pretty useful, like some manipulation of string. If we wanted to just be fancy and we wanted to make some type of header, use a single quotation, as it doesn't really matter. So I could do 3 stars or star dash star. And we wanted to repeat it 10 times, kind of like a header. We could have another one. We could have something in the middle. Say you want a prize. The repeat method will say do this 10 times. So I'll have effectively 30 characters in total, so it'll be quite long. But I'll have that whole thing, you win a prize, you want a prize, and then the whole thing again. So it repeated it 10 times. If you see, it kind of overlaps the asterisk. So if I didn't want to do that, it's just a small fine-tuned thing, and it'll go back and forth. And then another little useful, oh god, my throat got nasally, I'm sorry. Another useful thing that we can do, if we had a total a price, we had 30.4, and we wanted it to, I'll do a more complex number, 30.429, just a bunch of gibberish really. I wanted it to round it or fix it to a certain amount of decimal places. It's not necessarily rounding, but we want to say truncate it off of 42. Then we could do total.toFix, and we'll put how much decimal places we want. So let's say we put 3, so it'll be 422, so it rounded it, 422. Then it'll cut it off at 3 decimal places like this, and 9 will make the 1 round up. In other languages, might be a little confused to do this type of rounding, but in JavaScript they have a very unique way. Now you're probably wondering, how did we do a direct function onto this number? Because number is a primitive. So what happens is JavaScript, the environment actually makes a wrapper class and a wrapper object for this little total, and it will turn it into an object for a second, perform this operation, to fix, and then it'll turn it back into a primitive for a bit. Oops, I have the hiccups. Okay, I think I'm good. It'll turn it back into a primitive for us. So that's how it runs an object directly on a primitive like that. So now I'll go over REST operators and stuff. So if we had a class list that just takes in some args. Oh, did I skip? Wait a second. Sorry about that. Must have no, I'll go over REST operators now. I'm sorry. So if we had some function class list and it has args, and we'll define it something new I haven't showed, an arrow function. What this means is we'll have some list of args, some amount of variables that they'll pass through, and this defines it as an arrow function, which has the equivalent of saying something like class list .args, and just like that. This has the equivalence of this. We're just defining it as an arrow function, which just looks like a little arrow, so that's why we call it an arrow function. So there's some benefits to the arrow function, but for now we'll just show some implementation of the REST or this spread operator. So if we had students and we wanted to make a class list of all of them, we could use map the array, which takes 2, and we could say students dot plus equals student, which would be a loose implementation. So it won't print out the fanciest, but we'll have a printout. Instead of logging it here, we'll actually show some more object-oriented code. So we'll return students. We'll isolate this to just map the students to the student class or student variable. To make it just a little bit fancier, I'm gonna add a comma between each one. The final one's going to have a comma, but that's okay. Just for this demonstration, It doesn't really matter. So this arrow function, we'll just call it as such, and we'll put in some array, some amount of args. So if we wanted to use like my name, we'll have another Tom, we'll have another Tony, and we ran it, we'll have Zach, Tom, Tony. So this arrow function is acting, this arrow function is acting like a function. It takes this amount of arguments of which we didn't define. That's the important part. You see how I put 3, but I only put 1 here? If I defined 1 here, it won't even map it. Like, it can't even map because it's a single argument. But if I said, like, students equals args, it'll just say that. It'll just say the first one. So we use the spread operator when we want them to be allowed to use multiples. So if we use the spread operator, like such, we can use all the variables, and we can pass it as kind of like exactly like a collection list, however you want to call it. And we could use methods just like a list. If we wanted to, like, the cool thing about this, if we wanted to say year, like graduation year or something, and their graduation year is 2020 or something, I guess they already graduated, then we could add here graduating class of 20. Oh, I won't import 2020. I'll add the year. So graduating class of 2020. I did not put a space, so I guess I will. Graduating class of 2020, Zach, Tom, Tony. If you wanted, you could put a colon too. Just for this demonstration purposes, it doesn't really matter. So these spread operators like really useful for allowing the user to define after the set argument an amount of variables that you don't necessarily know. You could also define that they have to pass a list, but then they have to make a list, and then they have to pass the list here. So this has just smoother syntax in general. Why do we need the index in .map? So we don't, but with .map, it's just like most languages have like you need to pass both, and I'm used to it. So in JavaScript, like we saw earlier, if we just had, like, if we removed year or something, we removed this spread operator, and we use args as just a variable, it ignores the others. So if we do put index, it'll just ignore it. It doesn't matter. We could just put student. But let's say we wanted to do something with the index that student is at. So like, I'm not sure, like the index also, we have another array that's their GPA, and we use that index to get their GPA. So that's why we would use index, but we don't necessarily need it in the .map. Like this is called a callback function, this is an arrow function, and this is I guess it's the main use of an arrow function. It's probably the most useful use of an arrow function, because we can't define a function inside this block scope, but we can define an arrow function inside this block scope. So we can run like this code, this callback here. If we wanted to use a function here instead, we'd have to define a function here, and we could say add students or something. And we would write the code here, and we would reference add students, just like that. We wouldn't run it, we would just reference it like that. That's what we mean. We can say functions are like objects. I won't be showing that implementation. I'll just be moving on really quick. So let's say we had some numbers, and this is constant, not for any particular reason. And we wanted to use a function with it. So if we had like the sum of all the numbers, like y, z, and we returned x plus y plus z, and we have these numbers and we wanted to find 1 plus 2 plus 3, we could use a spread operator just like before to run sum with those 3 numbers instead of calling them like numbers.x or .0 numbers 2. Instead of calling them like that, we could use the spread operator to unpack numbers. So now it'll just be like the array, just like this. So when we use it to pack, we'll use it like in a parameter, and we'll pass it into it, and it'll put this into a list for us. Now we have a list, and now we're unpacking it, so it's not going, we're cutting this and putting it in there. So if we run this, we'll have a 6, because 1 plus 2 plus 3 is 6. So that's like another use of the spread operator, and we can also define like new numbers. use the spread operator here too. So we could do dot 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 numbers, and we could add, we'll skip 5 just to show, 6, 7, 8. And if we log the new numbers, ooh, this spelling is terrible. Have the old array, 1, 2, 3, and we'll have the 1, 2, 3, 4, and we'll have the new values 6, 7, 8. So the spread operator has put numbers into here instead of some convoluted way with like accessing each one like this, which would be very lengthy indeed, especially if the array is extremely large. And if it's of some undefined size, then it's impossible to know when to stop. We could also do this with like variable names. So let's say we had some colors, and we had red, green, blue, and we wanted to unpack them into variables. So red, green, blue. I'll explain that in 1 second. So the dot 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 actually doesn't say the numbers of values. Maybe I gave a perfect example for that, but I'll show numbers equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we had this whole array, and we did new numbers equals dot 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 numbers. It unpacks all of it. It has to be 3 dots. If it's 2 dots, that's like not syntax. If it's 4 dots, it's not syntax either. It'll actually give you an error in most text editors / IDEs. So if we added 11, 12, 13, 14, 15, 16, 176, I guess, that's fine, and we logged it, we'll have this gigantic array of both of them combined. It just cuts this and pastes it right into here. That's what the spread operator does. So if we have some undetermined amount, like this is 10, then it's going to add 10 new elements to numbers here. If we put it somewhere else, like over here, it would just put it here. It'll add them afterwards, 11, 12, 13, 14, 15. Webcam cut out, like my webcam. I'm sorry if it did. Is it okay now? The workshop's almost ending, so I'll get on to the final unpacking and stuff. Alright, okay, cool. Thank you. So what I've done here is I've defined colors as an array of red, green, blue, and now I'm accessing the red, green, blue. I'm not saying that these are the same, so I can call them RGB equals colors. So now it unpacks red, green, blue into the 1, 2, 3. So how kind of you were saying that dots imply the numbers value taken? This does imply the first element, or the 0 index, this first, second element, the first index, and the third element, second index. So if we print green, which will be green, which is G, it'll print green. And if we print the equivalent in colors, which is the first index, second element, it's green. So we can name these anything. We can name this like Tom, I'll name it Teeny. I'll name this Bob, Tiny. It doesn't matter. So if we reference Tom, that'll put red. So we've unpacked this list into these variables. If we didn't have Bob, well, Tom and Tiny really don't care, and they'll just take the first 2 elements. Let's say we had an object that had a name. We'll use Tom, and had an identification number, so an ID, which I'll put lowercase just for usual purposes, and we'll have like 1, 2, 3, 4. That's Tom's ID. Don't tell anybody else. So if we wanted to unpack these 2, we could actually use this, and now we can log name and ID. So this basically takes the properties with these curly brackets rather than the hard brackets. It takes those properties and it puts them from user into these 2. So it creates new name and ID. So that's like this is pretty useful if we went into anything else. So if we said like, I don't know, Tom here or something, or something else, it won't actually set name. We need these to be the same as the property names. So we're using curly brackets because we're accessing properties of an object. Before we were accessing an array, and if you don't remember, arrays are defined like this. Properties are defined, an object is defined like this, and its properties defined with a key and a value. I'll need to set this equal to some variable. But that's how properties are defined. We have a key and a value, and we're unpacking the keys into like this. But unlike a list where we don't really define, like we don't define a specific name, because properties each have a key, we want the same key here if we want to unpack it. So this is useful if we're going to use user.name a lot, then we're going to unpack it like this. Or if we're just name and we don't want ID, or if we want just ID, then we'll replace name with ID and it'll work exactly the same. And now we can access user.name. Instead of user.name, we can access it like name. Okay, so I couldn't really get through the whole slideshow through this workshop. This workshop is only an hour. But if you guys have any questions, you guys can hit me up on Discord. I'll be free to answer any questions. The rest of the slideshow, I'll just quickly play it. So in the YouTube video, you guys can go over it slowly and read it off if you want and ask any questions in Discord or anything. I'll be happy to help. So after object types, I was going to go over functions, which I did go over. I kind of went through each one. So functions, we said the scope enclosures. We defined a little bit of return. Answer your question right after I'm done. We're almost ending, so I'll be sure to answer your question. Arrays, we define them as such, and we can use them with for loops. So we'll be able to loop through like a length. Objects are exactly like we defined. We also define the function like definition of an object. And these are 3 links that you guys can use to, they're really good Java resources links. This Marcella has really good documentation on a lot of the JavaScript stuff, so I highly recommend if you're the type to read, then definitely look at their website. If you guys have any questions, I'm free to answer them. I'll answer that quick question. I'm typing const user equals this, name ID, let name equals user. Okay, that seems about right. You have the constant equals, I get a syntax name, same name is already declared. You might have declared it before in your code, or so if I'm reading it right, you have basically this, and then you just print name, right? If I go to my index.html and I refresh, it'll print mine. Could you tell me which line you're getting the syntax error and I can help you? The workshop ends in 2 minutes though, so you might need to message me on Discord. I will give you guys my Discord number right now. It's at Zachary. Oops. 6049. My Discord name. If you guys want the links that I put in the workshop, I have them right here. I'll copy and paste them. So let me pull up this real quick. If you guys want the links real quick. That's the first one. The second one. And there's the third. So if you guys don't have any questions, I'll be ending the workshop now. Thank you guys for participating and watching.